Hello Vikings! Today we're going to be talking about chemical equations. Our objective eventually is to learn how to balance equations. Today we're just going to learn a technique to be able to look at an equation and decide whether or not it is a balanced equation. So we need to know what equations, why we even write them, and so I'm going to go back on the next couple of slides and review a couple of the notes that we went over earlier in the semester when we looked at physical and chemical changes. And it's important that you understand the difference between these two as we start talking about reactions, because they're very different things. So when we looked at physical changes, some of the things we talked about were things like cutting, coloring, crushing. And the picture that I have on the slide, you have someone cutting a pink ribbon. And when you cut that ribbon, the ribbon is still ribbon even though it's a different size. So you haven't changed what the item is. So you have a change. It's only affected its physical properties. In this instance, with the cutting of the ribbon, the only physical property being changed is the size of the ribbon, but it is still a ribbon. But when we look at a chemical change, we looked at things like burning, rusting, and decomposing. And when these things occur, it occurs as the items are changing into a new substance. And so when we write chemical equations, what we're actually doing are illustrating these chemical changes that are occurring, and we're breaking it down into what elements are reacting. And there's a certain set of rules that we use when we're doing this. So very important, chemical change, you're actually creating something that is completely new. Okay, so a chemical reaction is that process where we take some atoms of one or more substances and we're going to rearrange them to form something new. So we call it a chemical reaction. And here's an example of an equation that shows a chemical reaction. And we have hydrogen combining with oxygen to create water. Okay, so we've put two things together, hydrogen and oxygen, and we've created something completely different, which is water. All right, so here's an example of another equation, and we want to start learning what some of the parts of the equation mean and how we can balance and those sorts of things. So the first thing you might notice is right in the center of the equation we have this arrow, and the arrow means yields or produces. Okay, you're also going to see numbers sometimes in front of your elements. You see this 3 in front of the hydrogen, the 2 in front of the nitrogen. These are called coefficients, and we talked a little bit about those yesterday. So these are just those big numbers in front of the elements or compounds in your equation. And we had 2 in this example, the 3 in front of the hydrogen, the 2 in front of the nitrogen. So just to keep it consistent, we're going to use the same equation again. And explain what reactants are. If you use the arrow as the center of the equation or like the center of a seesaw, the reactants are all the items that are on the left-hand side. Okay, we sometimes refer to them as the ingredients because most often you're putting things together to create something new. Then if we look on the right-hand side of the arrow, you'll see the blue are the products. In this case, you've only got one product being created. Okay, so anything on the right is called a product. Anything on the left is called a reactant. So again, right here we have a chemical reaction illustrated by a chemical equation. We've taken a nitrogen gas and a hydrogen gas and produced ammonia. All right, so here is another equation. This one's a really large one, and I wanted to show this to you. Not only does it illustrate coefficients, and it also illustrates subscripts, which are, you can see illustrated in red. But you will also notice that this equation adds another step to it. Not all equations are illustrated like this, but you will notice after copper there's an S in parentheses. After the silver nitrate there's an AQ in parentheses. So you'll see these little letters with parentheses around them. And what they stand for, I'm going to show you on the next slide. S would be solid, L is a liquid, G, of course, gas. And when we get to AQ, that simply means aqueous, because a lot of times we will take some sort of chemical compound and dissolve it in water, and that's when we call it an aqueous solution. Alright, so what we want to learn today is how to know if an equation is balanced. And how can we figure that out? We can use the information that we started learning yesterday to count atoms. And this time we're going to count the atoms on each side of the arrow to see if they are equal. And I have an illustration below. We have CH4 plus oxygen, and it yields carbon dioxide and water. So if we go through this illustration, they have listed all the elements on the left. You see carbon, hydrogen, and oxygen. You also see the same elements listed on the right, carbon, hydrogen, and oxygen. Because when we put things together, like in an instance where we're adding hydrogen and oxygen to create water, we're never going to have hydrogen plus oxygen equals water and nitrogen. Because whatever we put in on one side has to equal what comes out on the other as far as the amount of atoms. Because we don't create matter or destroy matter in a reaction. Okay? So looking at this, if we just look to the left of the arrow, we see the reactants. And if we look through all the reactants, we should see that there is only one carbon atom, and that's why we have the one below. You can see there are 4 hydrogen atoms on this side, and if you look at oxygen, you'll see that there's 2. So we have listed all the elements that are on the left-hand side and put the amount of atoms of each. So on the right-hand side, we're going to have the same elements, but they're in a different order. Whereas on one side, we have a hydrocarbon and oxygen. On this side, we have carbon dioxide and water. But they still, both sides, only have carbon, hydrogen, and oxygen. So let's count on this side, and we're in the product side, right? We have 1 carbon, okay? And over on hydrogen, you see the 2 in front, which is the coefficient. You have the 2 subscripts, so remember you multiply those, and that's how they get 4 hydrogen. Now when it comes to the oxygen, remember we're looking at the arrow as kind of like a seesaw. It's got to be completely balanced. So when you're counting oxygen on the right, you have to count all the oxygen no matter where it is. So if you look in the carbon dioxide, you will see that you have 2 here, and then in the water, that 2 in the front of H2O applies to all the elements after it. So there are 2 here also. So 2 plus 2 is 4, and that's where they get the 4 down below. So when we look at this equation, we have 1 carbon on the left, 1 carbon on the right. Carbon's good. We have 4 hydrogen on the left, 4 hydrogen on the right. That's good. But if you look at the oxygen, you have 2 on the left and 4 on the right. So if you wanted to look at this like a seesaw, there are less people on the left-hand side, and the seesaw is unbalanced, right? So this is not a balanced equation. Okay, so let's go through a couple of examples. And I'm going to pull up my sketchbook just because it makes it easier to do the tally so that I can help show you. All right, the equation we're looking at first is H2 plus O2 yields H2O. Is the equation balanced? Okay, so the first thing we would do underneath the equation, we would write every element that is involved in our chemical equation. And in this instance, we have a hydrogen, okay, and we have oxygen. And I find it easier to do this technique where you put the reactants over here and you put the products on this side and make a little chart, okay, to see if your seesaw is balanced. All right, so if we look on the reactant side, which is the left-hand side of the arrow, you will see that there are 2 hydrogen, and we also see on the left-hand side of the arrow 2 oxygen. If we look to the right-hand side, now we're looking at products. That's what the P stands for. How many hydrogen do we have? We have 2 over here. Then when we look at our oxygen, we don't have any coefficients or subscripts, so it's just 1. So we see in our little chart that we have 2 hydrogen on the left, 2 on the right. Our oxygen, though, we only have 2 on the left, but only 1 on the right. So is our equation balanced? In this case, our equation is not, because there are 2 atoms of oxygen on the reactant side and only 1 on the product side. And if you look at this like a seesaw, it's not going to be balanced. Okay. All right, so let's try another one. All right, CH4 plus 2O2 yields CO2 and 2H2O. Is this equation balanced? So let's do another chart. First, we're going to write all the elements that we have. We have carbon, we have hydrogen, and we have oxygen. Okay, so we've set up our little T-chart. Okay, and on the left, we have our reactants, and on the right, we have our products. Okay, remember reactants are those items on the left-hand side of the arrow. So let's take a look. On the left-hand side of the arrow, we have 1 carbon. Okay, looks like we have 4 hydrogen, and we have 4 oxygen. Remember, coefficient in front, we multiply it by that subscript for 4. Okay, so that's our complete reactant side. Let's see if we're balanced. On the right-hand side, our products, we have 1 carbon. Okay, we'll go ahead and do our hydrogen. 2 times 2 is 4. And then if we look at our oxygen, don't forget that we have to look at all the oxygen on the right-hand side, no matter where it is. So we've got 2 in the carbon dioxide, and we've also got 2 in the water, because don't forget we have that coefficient. So 2 plus 2 is 4. So when we look at our chart this time, we see that our carbon's balanced on either side, our hydrogen's balanced, and also our oxygen. So do we have a balanced equation here? Yes. This one is definitely balanced. And I gave you that one to show you the difference. Okay. All right, let's try another one. Okay. We have iron oxide, and carbon yields iron and carbon dioxide. Let's see if we're balanced. First, we're going to write all the elements that we have involved. We have iron, which is Fe. We have an O for oxygen and a C for carbon. All right, and we're going to have our reactants on the left, products on the right. So let's count our iron. Iron, 2 coefficient, 2 subscripts, so that makes 4. Okay, and oxygen, we've got a 2 coefficient, 3 subscript, that makes 6. And then over here, we've got this lonely carbon all by himself. All right. Then when we get to the other side of the equation, the products, we have 1 iron. Okay, it looks like this coefficient of 3. We've got 3 carbon, And it looks like 3 times 2, 6. So our oxygen's balanced, but our iron and our carbon are not. Okay, so if you were to look at it like a seesaw, you have 11 atoms on one side and 10 on the other. Okay. All right, so this one is not balanced, and there you go. Okay, so I hope this helps you. Today, after this, I'd like for you to practice a few equations just to see if they're balanced. Also, I want to encourage you, for some of you, the chart you may not like the chart. I, for one, like to do it in my head. If you can do it that way, that's perfectly fine. I just always try to show different ways because we all learn and do better using different techniques. So I hope you have a wonderful day.